Variable stresses. Question number 23. In cyclic loading, stress concentration is more serious in option A brittle materials, option B ductile materials, option C brittle materials as well as ductile materials, option D elastic materials. So stress concentration is more serious in ductile materials. So cyclic loading. What is cyclic loading? So consider a shaft. So it is kept between two bearings. Okay, it is supported between two bearings. So it acts like a simply supported beam. A load W is acting, and it is AB, one half of the cycle. For 180-degree rotation of the shaft, it is under tension, and remaining 180-degree rotation of the shaft, it is under compression. So this is called as cyclic loading. One half of the rotation it is under tension, and remaining half of the rotation it is under compression. It is alternatively changing tensile, compression, tension, compression. So it is called as cyclic loading. So it occurs under dynamic condition. It is also called as dynamic loading. Under static conditions, this type of condition will not occur. In cyclic loading, okay, usually it will fail under well below its yield point. Okay, in cyclic loading, materials will fail below its yield point, but usually materials will elongate or it will fail at the yield point. Okay, but under cyclic loading, the material will not stand up to the yield point. It will fail well below its yield point. This phenomenon is called as fatigue phenomenon, and this failure is called as fatigue failure of materials. And the strength associated with the fatigue phenomenon is called as endurance strength. It is sigma minus 1 or sigma E because of cyclic loading or dynamic loading. So you cannot design based on sigma Y. You have to design materials based on sigma minus 1. Sigma minus 1 is always less than sigma Y. Okay, it is variable stresses. One half it is tension, remaining of compression, tension it is compression. This type of stresses are called as variable stresses or cyclic stresses. Endurance limit. When a material is subjected to variable stresses, it fails below the yield stress. Such type of material failure is called as fatigue failure. Okay, so this limit is called as endurance limit. Okay, the fatigue stress is called as endurance strength, and the fatigue limit is called as endurance limit of the material, like the yield point, the endurance limit of the material. Okay, so maximum stress below which material will not fail even subjected to any number of cycles is called as an endurance limit. So this is a specimen, and this is a fatigue testing machine. This specimen is placed in the fatigue testing machine, and in this machine alternative loading, that is tension compression cyclic loading is applied, and the variable stresses are applied on the machine, and the revolutions of the machines are noted. Okay, the number of revolutions of the shaft, okay, the specimen is noted in a counter. Okay, the number of specimens, number of cycles are plotted along the x-axis and the curve in the bottom. Okay, number of cycles is plotted, and the stress values are noted, and this curve is called as SN curve. Okay, SN curve, it is very important in the design. Okay, design under variable stresses, SN curve. Okay, the SN curve, first it starts decreasing. After a certain point it becomes asymptotic, or it becomes a straight line after some point. Okay, under less number of cycles stress value will be more, but after 10 power 6 cycles, okay, after 1 million rotation it will be under, so it will be same, and this point is called as this line is noted down, and this stress corresponding to this line is called as endurance limit stress or sigma E. Sometimes it may be called as sigma minus 1. Sigma E or sigma minus 1 is a endurance limit strength. Okay, we have studied different types of stresses: tensile stress, compressive stress, shear stress, torsional shear stress, but this is a different type of stress. It is a fatigue stress or endurance limit stress. It is denoted by the symbol sigma minus 1 or sigma E. Okay, it occurs due to variable stresses. This type of fatigue occurs to variable stresses under dynamic condition, under dynamic loading, under moving parts. This type of stress will occur. We have to design based on this sigma minus 1. We have to design the materials based on sigma minus 1, not on sigma y when it is subjected to variable stresses. When a material is subjected to variable stresses. For steel, sigma minus 1 is 0.5 into sigma u. For cast steel, it is 0.4 into sigma u. It has a half of this value. For cast iron, it is 0.35 into sigma u. Okay, you have SN curve. So SN curve, the SN curve, stress, number of cycles. Okay, it is called as SN curve. SN curve becomes asymptotic at next question. The SN curve for the steel becomes asymptotic nearly at 10 power 6 cycles. 1 million cycles. So answer is C. Next question. Consider the following statements. Endurance strength of a component is not affected by its surface finish, not sensitivity of the material, but it is affected by surface finish and not sensitivity of the material. So one is wrong. For ferrous materials like steel, SN curve becomes asymptotic at 10 power 6 cycles. So option 2 is correct. Statement 2 is correct. Which of the statements are correct? Statement 2 only. Statement 2 only is correct. So option is B. Failure of a material is called fatigue when it fails below the yield point. Okay, it is not below elastic point or above elastic limit or above yield point. So failure of a material is called fatigue when it fails below yield point. So option is C. Fatigue. So the maximum stress is less than the ultimate strength or yield strength of the material is called as fatigue failure. Next question. The resistance to fatigue of materials is measured by endurance limit. So the fatigue strength is measured by endurance limit of the material. Fatigue life of a part can be improved by short peening. Short peening operation improves the fatigue life of a part. Okay. Failure of a material is called fatigue when it fails below the yield point. Okay. Failure of a material is called fatigue when it fails below the yield point. Option is D. The endurance or fatigue limit is defined as the maximum value of the stress which is polished standard specimen can withstand without failure for infinite number of cycles when subjected to completely reversed load, tensile compressive, completely reversed load, not static load or not dynamic load, not static as well as dynamic load, it is completely reversed load, tension, compression. Okay, so option is D. Okay, endurance or fatigue limit is the maximum value of stress which is a polished specimen can withstand without failure for infinite number of cycles. Then 31. The yield point in the static load is higher compared to fatigue loading. Okay, fatigue loading the load will be less, so yield point it will be greater. So option is A. The endurance limit is of primary concern in the design of an rotating shaft. One statement one is rotating shaft, 2 industrial structure, 3 column, 4th one machine base. So it is not of importance to industrial structure, column or machine base, it is of importance to rotating shaft. So option 1 is correct. So statement 1 is correct. So option A is correct. A stress which vary from minimum value to maximum value of the same nature is called as fluctuating stress. Okay, fluctuating stress. We'll see this here. It's a fluctuating stress. Minimum value to maximum value of the same nature is called as fluctuating stress. Option is C. Next question. Fatigue strength of a rod subjected to cyclic axial load than that of a rotating beam of the same dimensions subjected to steady lateral force because. Okay, option is D. Compare the two things are given. One is a rod, another one is beam. Okay, first one rod subjected to cyclic loading, another one beam subjected to steady loading. Okay, that is it is then cyclic load than that of. Okay, so at a particular time the rod has only one type of stress, whereas the beam has both the tensile and compressive stress. Okay, fatigue strength is greater for the beam. Okay, because beam has both the tensile and compressive stress, but the rod has only one type of stress because it is subjected to cyclic axial load only. It is not subjected to the steady lateral force. Okay, option is D. So in the mean and variable stresses, the mean stress is sigma max plus sigma minimum by 2. Okay, now we are going to study the Soderberg and Goodman equation. For this we are in need to understand mean stress and the variable stress. Mean stress is, so it is a sigma max, maximum stress is a minimum stress, bottom one is a minimum stress, this is a maximum stress, sigma maximum plus sigma minimum by 2, it is a mean stress or average stress, and variable stress is sigma max minus sigma minimum by 2. Okay, mean stress and variable stress, sigma m, sigma v. Mean stress is sigma max plus sigma minimum by 2, variable stress is sigma max minus sigma minimum by 2. And the factors affecting the endurance limit are load factor, load is affecting axial load, reverse load, torsional load affects the endurance limit, and surface finish factor, polished surface and everything affect the surface finish, and the size factor and the size of the components also affect the surface finish. The factor of safety and stress concentration, factor of safety equal to endurance limit stress divided by design or working stress. Stress concentration is equal to maximum stress by nominal stress. Okay, in the stress concentration, so the lines are parallel and in this place, that is whenever there is a change in cross section, that is stress concentration is changed, so stress concentration will be more. So at this place stress concentration factor Kt equal to maximum stress by nominal stress. Fatigue stress concentration factor, endurance limit without stress concentration divided by endurance limit with stress concentration. Notch sensitivity is also given. Here a machine component problem is given, and you have to solve according to modified Goodman relation. You have to solve the problem using modified Goodman relation. Okay, so the modified Goodman relation, so there are three relations. One is a Soderberg line and another one is Goodman line, another is a Gerber equation. So here sigma y and mean stress is plotted along x-axis, variable stress is plotted along y-axis. Okay, if you join sigma e and sigma y, it is a Soderberg line. If you join the endurance limit stress sigma e or sigma minus 1, if you join sigma e and sigma u, okay, or sigma minus 1, it is a Goodman line. Okay, and if it is joined by, instead of joining by, if it is joined by parabolic, it is called as a Gerber parabola. It is called as Gerber parabola. If it is joined sigma 1 and sigma y, it is called as Soderberg equation. If you join sigma minus 1 and sigma u by a straight line, it is called as Goodman equation. If you join by parabola, it is called as a Gerber parabola. So the Soderberg equation is 1 by factor of safety, the Soderberg method. Okay, sigma minus 1 and sigma y is joined, 1 by factor of safety equal to sigma m by sigma y plus sigma v by sigma e or sigma minus 1. Okay, 1 by factor of safety equal to sigma m by sigma y plus sigma v by sigma e. So factor of safety equal to sigma mean stress plus sigma y is yield strength and sigma v is a variable stress. Sigma mean equal to sigma max plus sigma minimum by 2 and sigma v equal to sigma max minus sigma minimum by 2 into stress concentration factor Kf, and sigma e is a endurance limit strength. Here sigma m by sigma y is a yield strength and sigma v by sigma e is a endurance limit strength. So it is a Soderberg formula. And in Goodman equation, instead of sigma y, it is 1 by factor of safety into sigma m by sigma u and sigma v by sigma e. Okay, instead of in Goodman Soderberg formula, we have to substitute sigma y. Only difference in the Goodman equation is instead of sigma y, it is sigma u, as it is connected to, because it is connected to sigma u. Only difference is 1 by factor of safety equal to sigma m by sigma y plus sigma v by sigma minus 1. Okay, in the problem, so a machine component is subjected to flexural stress which fluctuates between 300 meganewton per meter square and minus 150 meganewton per meter square, taking the yield strength equal to 0.55 of the ultimate strength and endurance strength equal to 0.50 of the ultimate strength and factor of safety to be 2. The value of the minimum ultimate strength according to modified Goodman relation will be, okay, sigma m. Okay, sigma m is, so it is 300 minus 150. Maximum stress is 300, minimum stress is 150, So 300 minus 150 divided by 2, and variable stress is 300 plus 150 by 2.